At Simio, we're in the business of showing you the future. Our intelligent technology gives you unprecedented insight into complex systems to identify and solve today's inefficiencies and tomorrow's challenges. The Simio solution provides a low-risk opportunity to drive transformational change. Our true digital twin models capture all the constraints, business rules, and decision logic that define the operation of your system. When powered by your data, easily evaluate unlimited scenarios and deliver optimized solutions. No matter what industry you're in, eliminate your greatest operational process and scheduling challenges with a Simio digital twin. See your future success, Simio.
Welcome to the Simio Solution Series, special edition August here. We originally were not going to do an August session, but we came up with a topic, so we'll get right into it. Today's session is, what exactly is my model doing? Verification and debugging techniques. My name, as always, is Dan Vasilini. I'm the VP of Global Sales over here at Simio. Presenting today is going to be Madison Evans. Madison is one of our Simio academic team members. You'll see the QR code on this page as well as a couple slides later. We do ask that if at some point during today's presentation, if you're watching live or if you're watching this on recording, to please scan the QR code and give us some feedback. We're always looking for feedback on how our sessions are, what type of future sessions you may like to see. Any type of feedback we can get is always very welcome. So please feel free to scan the QR code and get into it. All right, a few housekeeping items before we get started today. First off, today's session is being recorded for replay purposes. Please be aware, if you'd like to watch this session or go back and watch it or suggest it to a colleague or a friend, we will post this session on Simio's webpage. Usually it gets up in about 24 to 48 hours after we're done with the session. If you go to the Simio webpage, under the Resources tab, you'll see a Simio Solution Series, and you will see this session as well as all of the other sessions we've been doing available to you there to watch on recording. You will also see the list of future webcasts that we're going to be doing, and I will talk about those here very shortly. Also be aware, all participants today are on mute. If you need to or want to ask a question during today's session, please feel free. Somewhere on your desktop, it should be a GoToWebinar dashboard. In that dashboard, there is a question box. Just simply type your question in there. Those questions come directly to me. And if the question is relevant or pertinent to the topic that Madison is talking about, I will try to interrupt her and ask the question at that point in time. Or if the question is more generic in nature, I'll try to hold the question until the end to keep the flow of the presentation going. Madison has about 35 to 40 minutes or so planned for today's presentation, so there should be time at the end for questions. But we left that time at the end for questions just in case. As I mentioned, future sessions coming up. So we have 3 more remaining here in 2024. We have a September, an October, and November. You'll see what they are right there. September the 12th, October 17th, November 13th. And you can see the topics there. And like I said, just go to the Resources tab on the Simio webpage. You can drop down to the Solution Series and register for any of these or all of these so that you can get there. So thanks for attending today. Once again, there's that QR code. Once again, if you are watching this session live or watching on a recording, please scan that QR code, give us some feedback. We're always looking for it. With that said, I will turn things over to Madison, and she is ready to go.
Awesome, let's jump in. Like Dan said, I am Madison, and I am part of the Training and Academics Program team at Simio. And today we're going to cover a few verification and debugging techniques. Definitely not all of them, because there's so many that it's hard to cover them all in a small session. So let's get started here. First, I have an outline of what we're going to talk about today. I will be presenting 2 different models, a machining operations model, and a pet food model. We'll spend the most time with that machining operations model, setting up a context for the model so that you can kind of follow along what's going on and how we chose to model. Once we set that context for the model, then we'll dive into the verification and debugging portion of the presentation. The first thing we'll cover is how to create expectations and why it's important to create expectations. And then we're going to cover a few tools for verification and debugging. This is by no means, again, an exhaustive list of all the available tools. These are just the ones that we decided to cover today. So we'll discuss status labels, watch, breakpoint, trace, dynamic text, and point queues. Some of these you may be familiar with if you're more on the expert side of modeling, and some of these you may be less familiar with if you're kind of newer to this whole process. And some of these, even though you may be experienced, you may have forgotten about. So it's always good to remind ourselves about what tools exist. The second model is a pet food model, and we will be showing how to use watch and trace to track row references. Now that we've kind of talked about the outline, let's jump into our machining operations model. So we're going to talk about what the context is for the problem and then show you how we chose to model this. So we have a two-machine operation system. We have a lathe to do turning and a CNC machine to do some milling and surface finishing. After the CNC machine, an operator conducts a quick visual inspection of the part and determines whether or not the surface finish is desired. If it is not desired, the operator sends that back to the lathe, and typically a high number of them get sent back because of just the sensitivity of the surface finishing. Operators at the lathe know to prioritize parts that are sent back from the CNC machining. That way they can meet their deadlines on time. After a part has been approved by the operator at the CNC machine, there is another inspection that it's its own station because it takes a little bit more time because we're checking with measurement tools to see if those parts are within the tolerance. A part's likelihood of failing this inspection increases proportional to the number of times that it's been machined, as these are material removing operations, and therefore it is more and more likely that it will not fit within those geometric tolerances. If a part passes inspection, then it is sent off to shipping, and if it does not pass inspection, it's sent to be melted down so that it can be used again. So with that, now we're going to jump into our Simio model. So here is our beginning Simio model, and you can see we have the two machines and the inspection station, our two sinks for where the parts are going to end up, and we have our loop that takes parts back to our lathe machine. So at the loop, we have different selection weights that are probabilistic, just indicating that we have a high number of parts that have to go back to the lathe. So we have a higher probability on the path that is returning and a lower probability on the path that goes to inspection. At the lathe, we use a ranking rule to order the parts for prioritization. And we also have a state assignment after processing that helps us keep track of the number of times a model entity has been processed. And that state is on the model entity because we want it to be unique for each model entity that comes through our system. At inspection on the output node, we have an add-on process trigger at the exited that does a decide to just see whether or not a part has been processed more than 2 times. This is a simplification from the context that we talked about in the PowerPoint. And the reason we did this simplification is to make the verification process easier to start off with. So we're going through, we're making sure that the branching is working and the placement of things is right before we add the added complexity of figuring out how to make this decision proportional to the number of times it's been processed and adding in that probability component with that proportional component. And so this will reject a part and assign it a bad title if it has been processed 3 or more times. And then back in our model on the pass, we have a selection weight where the passer, the entity is looking to see if it matches the statement, which is either that equality, another model entity state is equal to good or bad. And so now that we kind of talked about how this model is built, we're going to run it and we're going to kind of watch and see what happens, because this is something I always recommend to people is definitely watch your model so that you can see what is going on and see if what's happening matches with what you expect. So as we're watching, we can see that we have things going to both sinks, we have things going around. So it seems like everything in this model is working. But actually, there are 2 different problems in this model that we're going to cover today that would not be caught unless you spend time opening the hood of your model and figuring out what exactly is going on. Many of you use your Simio models to help you make important decisions or gather information about systems of interest. If there's no proof or evidence that your model works as you intend it to work, it's going to be difficult to use these models. Therefore, it's really important that we spend time doing verification, debugging, making sure there's no problems in our model, and that we also refine our expertise at doing these things. Because right now we're looking at a pretty simple model, but just picture if this was triple, double the size, there was multiple things going on, it gets a lot more complicated the more difficult of a model that you're looking at and trying to debug. So before we kind of start covering how to go through and debug this particular model, I want to flip back to the PowerPoint and talk about 2 different tools. The first tool is Watch. Watch lets you see all the attributes of an object instance during a run when that run is paused. An attribute of an object may be a built-in state, may be a user-defined state, may be table references or functions. All of that is contained right there. And to get to this watch, you right-click on an object and click watch in that menu. And we'll do this in Simio so that you can see what it looks like live as well. But just wanted to make sure that we cover this since this is such a big important part of the presentation. Also, just to review for those of you who know about Trace or for those who maybe have never used Trace, Trace is another really important tool when you're debugging and verifying. People with model experience probably know and hate Trace or know and love Trace, depending on how well verification has gone. It kind of using Trace and starting to understand all of the things that happen in your model take you from a beginner Simio user to a more experienced Simio user. So Trace allows you to see exactly what is occurring during the simulation with each step that occurs. This lets you walk through the simulation events and determine whether the logic that you've incorporated is working as intended. And to open a model trace, you go to the run setup and click on that model trace option. You should be strategic when you decide to use model trace. If you want to capture the entire run, start it before you do your run. If you're just looking at a small part and you don't have to want to look through a bunch of different information, you can start it at a certain point, and we'll kind of show you that in the presentation. keep in mind, running trace will slow down your model some. So that's another reason why you might want to wait to open it instead of opening it at the beginning. Also, a thing of note that's a little new and is in the newer versions of Simio, we've given advanced options for trace so that if you want to trace all the row resolutions, then you can do that. But it makes it much bigger than the regular trace, so just use that carefully. So now we're going to go back to our Simio model and kind of start that debugging verification process. So this is where we're going to cover expectations. So it's very important that you develop expectations of your model. These expectations could be numerical, meaning you're looking for your model to have a certain numerical result, and these numbers could be based on historical data or a mathematical model, but it's important that you be cautious just relying on numerical expectations, and that sometimes your expectations of how the system is working numerically can be wrong. Another way to set expectations is to change something in your model and expect a behavior to happen and make sure that behavior is happening. So that's what we're going to do first. Is we're going to make an easy change to our model because we have this loop that's based on a probability. So if we take out that loop, we know that everything should go to shipping because we're only going through the system one time. So let's make that change here by changing this selection weight to 0 and changing this selection weight to 1. Before we kind of run the model, we're going to add something as a double check. So the way I built my model is I used time pass so we could see the entities moving through the system. You can also see entities moving when you use the path. However, if you have any kind of instantaneous transfer or use the connector, you're not going to see things going into the sink. I like to use status labels, which show you the numerical occurrences, like number of occurrences during a run. It's very visual and it's a great way to just check and make sure that what I am seeing is matching numerically what is going on in the model. So to get to these status labels, you open the animation and you go to the dynamic text. There's also a floor label that works very similarly, but it has a little bit of extra features by letting you change colors, bold text. One of the big differences is you have to know what expression you're looking for and type it in yourself. On the status labels, you have the expression builder that can kind of help you if you're not really sure what you're looking for. So for our model, we're going to look at specifically how many things are going into the sink. So we're going to type our sink name. We're going to go to the input buffer, and then we are going to go to the number entered. And we're going to repeat that here for the second sink. Great. So now we have that done, and we're going to run the model, and we're going to speed it up a little bit so that we can get things to our sink faster. And now we see what we expected to be happening is not happening. We're having things going to both ways. So we know there's a problem with what is happening at inspection. So we're going to focus in our debugging process into inspection. And one thing that can be really helpful, especially when you have really big models, is a breakpoint. A breakpoint allows you to use the fast forward button to take you straight to when the first entity enters that breakpoint. using breakpoints is really helpful when you have a lot of complex logic, because breakpoints can be put on nodes, they can be put on servers, they can be put on paths, they can be put on processes. So we're going to just put a little breakpoint there on our node. And then we're going to fast forward the model, and we get our first entity that comes to that node. Now, like I was saying, you really want to be strategic with when you want to turn on model trace. So we could have turned it on before we hit fast forward, and then we would have gotten the entire life of all of the entities in that model trace. But to kind of reduce what we're looking at, we'll turn it on now, and you can see this window that pops up here. Then we also want to go ahead and start watching our entity and see what is happening with it before we go through the next step of the model. So we can make this window bigger, zoom out a little bit, and these windows are really useful because you can make them as big as you need them, you can change the column width, you can even undock the windows and open it and put it open in another monitor so that you can see it a little bit better instead of having to squish everything. But since we only have one screen for this presentation, we'll just keep it like this. Before we kind of dive into what's happening, just wanted to show you around watch a little bit. We have table references, which is really important when you've got a lot of tables and a lot of complex changes. We have processes, which shows you which tokens are active. And something that is a little different is these functions part. If there's something you want to see that you're not seeing, keep looking because there's lots of information here, and functions is a really great place to start because there's a lot of things here. You can see current node, current link, destination node, a bunch of information. You can also see here our times processed and our quality, which is the state assignment, the state that we defined in our model entity. So now we are going to focus on destination node to start with. When we step our model forward, which just takes it a few steps into the model, we see that our destination node and our current link have been changed to input at shipping. However, when we discussed how this model was working, we said that this should be based on our quality. So if we scroll back up, we see that our quality state has not been assigned. So the entity is making this decision and picking a node and a location before that quality is assigned. If we step forward a bit more, we finally see after the entity has left the node and already started on the path, we see that the quality is finally assigned, which is not the order of events that we want to be happening. So that gives us a good picture of the order of things. It can kind of help us when we go into trace to know exactly what we're looking for in a more simple way. So we're going to open trace, and there's still a lot of information in here. We have part 31, we have part 23, which is the part that we're looking at. And to reduce the amount of information that we're looking at and that we see on our screen, we're going to use this filtering section and pick part 23, which reduces the information so that we're seeing just what is happening with part 23. Like I said, if we had started this earlier, we would have seen the entire life of part 23 from when it came out of the source, going through both machines, and then finally arriving at inspection. But this reduces, again, what we need to look at. So now we can kind of highlight a few important parts of this trace. Here you can see that we are firing the event output inspection entered. This is really important because that's one of our add-on process triggers. We can also see that we fire the event output at inspection exited. So one of the important parts of Simio, as it is a discrete event simulation, is the order of events. And that is really important to keep in mind when you're modeling and when you're choosing to do state assignments, when you're choosing to do add-on processes, because you want to make sure the events are occurring like you want. So we can see this firing the output at inspection entered. We can see that we're transferring that entity onto the time path, meaning it's chosen its location and its destination node. And then we can see it ending that transfer onto that link. All of this happens before we execute the output inspection exited, which is where our add-on process is. You can see that we do the state assignment variable right here, a few different things after we've fired that event, but way after the node, the entity has already transferred out of that node and onto a path. So that tells us we need to change where we're doing that add-on process. So now we're going to kind of minimize that so we can see better what we're doing here. So now we're going to stop the model so we can make our changes, and we're going to just copy the name and move it over to the entered section. We don't have to go through, change the name yet, but that's something you want to do before you finish with the model so that it's clear when you look at your add-on process page where that add-on process is actually at in your model. But this is really nice for just testing and verifying so that you don't have to go and do a lot of work. So now we're going to fast forward again, and we're actually going to remove our breakpoint now so that we can get entities to flow through the system. And when we push play, we see that everybody is going to shipping like we expected them to.
Hey, Madison, real quick. Someone
Yeah.
wanted to know how do you go to the other model trace page?
Oh yeah, that's a really good question. So to kind of flip between the trace and the watch, I think you can see my mouse down here. There at the very bottom, there are two tabs, and you can flip between those two tabs. So that can take you from watch to trace, trace to watch, and it's pretty easy to flip between those two.
Perfect. Thank you.
Yeah, that's a really good question. Thanks for pointing that out. So I said there was two problems when we first started talking about this model. One of the ways that if you don't know how many problems there are, which is likely, you want to check all of the locations where you've changed something from default. So we kind of, through developing our expectations, checked this selection routing here, and we checked what was happening here. So now we need to go and check our ranking rule that we used at the lathe. So one of the ways that we're going to do that, because the ranking rule orders the entities based on the number of times processed, we need some way to keep track of how many times each part has been processed. And maybe we don't want to have to click watch and see, like, try to remember what values were there. And so we're going to add dynamic text to our model entity. So you click your instance of your model entity, which brings open the options, and then you're going to open the animation section, and down there at the bottom is the dynamic labeled text. Again, the expression builder is available if you aren't sure what you're looking for. If not, you can just type something. But we're looking for that model entity times processed. So now when we run our model, we're going to slow it down to make sure things aren't flying through. When we run our model, we see that all of the entities are coming with numbers at the bottom of them, and then we're seeing those numbers increment. One thing with using this dynamic text, depending on how big your numbers get and things like that, sometimes it can be really hard to see it in the queue. And so we're going to demonstrate point queues. Point queues allow you to separate out your entities, and we have a different model to show this point queue because it can sometimes take a little bit to set it up. So we didn't want to like bore you to death watching me put all these things, but I can definitely show you a little bit. When I click on the queue, you can see the appearance is moved to point, and there are several vertexes that can be moved around. Just a kind of side note, point queues are really good to make your animations look more realistic. For example, if you have a doctor's office and you want patients in the waiting room to be waiting in chairs, you can take a point queue, move the patients to those chairs, and then when you are viewing your model, you can go to these visibility and turn off queues, and then, come on, turn off. There we go. Now we don't have those queues, and it just looks like the entities would be sitting in their chairs and not attached to a line. This model has a few, so it's almost exactly like the model we were just working with, but I've added a few things to kind of demonstrate some of the different functionalities you can get. You can use status labels as titles by just entering a script phrase and giving that a little bit more information so you don't have just floating numbers. This is kind of an example of what those floor labels can look like and how you can change the colors. And then another thing that is really interesting to note is with all these numbers here, not only can we see how this line is working, but we can also see which numbers are going to the sinks, which would have helped us identify that there was a problem. So sometimes what you can do is you can add all these extra things to your model when you build it initially, and that can really help you identify problems rather than using it after you've determined there may be a problem and trying to figure out where it is. So it can be really good practice to incorporate some of these at the beginning of your models. Also, each of the entities have a floor label as well that travels with it. And this can be good is if you're looking for multiple different things about that entity, you can incorporate maybe a dynamic text and a floor label, or a dynamic text and a status label, so that you can get more information. So now if we focus on our lathe, we had talked about wanting to prioritize the fact that entities that had been through the process more should be processed first and not last. So we can see with these numbers and the point queue spread out that we are not getting that. And so that tells us there's some kind of problem with our ranking rule. So now we want to stop and we want to open up, and we see that instead of selecting largest value first, we accidentally selected smallest value first. And this is really common. Sometimes that can happen is if you don't click out of it and you click an up and down arrow or you scroll, it could randomly change the option that you chose. So that's a pretty easy fix. We just go in, switch it back, but it's not always going to be that easy. This is just a good way to show how to figure out if your ranking rules and your dynamic selection rules are working as you wanted them to work. So now we want to just run it again so that we can double check that now that we've made that change, we see the behavior that we want to see. And this can take a little bit because we want to fill out that queue and stop it at the right time. But now you see we've got a bunch of zeros in line and we've got a 1 and a 2 in process. So now we're kind of taking care of things like we wanted to take care of. So those are all of the major points we wanted to talk about in this model. So I'm going to pause, let us collect ourselves, and then switch over to our second model for the day. And this is going to be a pet food I was just dog sitting, and so I was like, and I have a cat, and so I was like, I don't know, pet food, that's fun. Because we have pets, and I felt like just 2 entities wasn't enough, so I threw in the fish food in there. So we have 5 different servers, and we have orders and a shipping location. This model is run using data tables. So I'm going to open our data tables and kind of talk through them. We have a part table, which has part types as a foreign key so that we can have related tables. And then we have a mix. This allows us in our facility to generate orders off of that part type table and do it using random row. The random row function returns a row index using the values in the column property as weights. So we're using that mix as weights. So if we go back to our table, we'll see we should have more dog food entities than any other types, and we should have the least amount of fish food entities. And then the second table we have is a sequence table. This allows us to specify different sequences for our different entities. And so we have 5 locations for our cat food, 5 locations for our dog food, and 4 locations for our fish food. Both the cat food and the dog food go to the make food, the cook food, bags, sealing, and shipping. The fish food goes to the make food and cook food, but goes to the cups instead of the bags and the sealing, because typically you're putting those fishy flakes in a cup and not a bag like you see with the dog food. We've also specified different processing times for each of these that are dependent on what the station is that we're at and what cat food we're looking at, because cat food takes a little less time to make than the dog food, and the fish food takes even less time than both the cat and the dog food. To see this in our model, each server references that sequence table and that processing time to make that assignment of what the processing time is. Also, each node uses the entity destination type by sequence. So now we're going to run our model, and we're going to get our first entity out there. Actually, I need to make sure we turn on model trace. So there's model trace. And now we're going to run again and pause because we've gotten our first entity there. And so we can go to the watch and we can open it, and then we can go to table row references, and then we can expand each of these parts. So table references, this first section right here, will typically show the absolute roll number in the table. This is a collection of the table references an item has, even if it was not explicitly set and was instead inherited in another way, like through table relationships. Explicit selections show the row that was consciously selected by the logic in the model. This explicit selection may be the absolute row number, or like in our case, if this is a table with relationships, it could be a related row number. The potential row count occurs when the item has a table row reference to a key, and that key has a foreign keys in other tables. So again, like the situation that we are seeing. This is really important to look at because table row references can be really complicated. In fact, it is so complicated that we have another solution series on understanding row reference hierarchy and changing row references. So if you want a little bit more detail on what's going on behind the scenes, that's really good to look at. So right now we see that this dog food has a row reference to the number 2 in the parts, and the sequence table has a number 6. So if we go to our tables and make this a little bit smaller, we can see in our part table that 2 corresponds to our dog food. So that makes sense. We want to have that part and we want it to be 2. And then our sequence table, we see that the potential row count 5 comes from the fact that there are 5 options for dog food. And then we see that it's specifically pointing at that 6th column. Now, if you look at the explicit selections, the sequence table is showing 1. And that is because we have this related table. So when you expand the dog food section, you see the first column is our 6th column in our sequence table. And so if we run a little bit more, we can actually wait for our dog food to leave the make food eventually. Now it's at the make food. We can see that our table row references, all of these have become red, which means it's changed from whatever it was before. And we can see that the parts, the sequence table have changed now. The sequence table has changed to 7, or the second one. And one of the things that I found really interesting about this is the reason why we can have, I did not want to go to the results. The reason why we can have this processing time and get it to relate to a location is because we're using that by sequence to change the row that we're at. If we didn't have that by sequence iterating through in a specific order, relating these processing times to just an entity wouldn't work. You'd have to do some different row setting. And then just to kind of show you, because we had talked about earlier, those advanced options in trace, which if we go back to facility, you can see if you go under advanced options and the trace type, you can see the table row resolution is checked, and you see a lot more information on what is going on in the table. And again, this is why like there's a whole large section of things for just one time period, and that's why it's really important to make sure that you're using that advanced option where you're looking at the table row references very carefully. So that covers everything that we had planned. So now let's get some of those questions, because I know I covered a lot in a little bit of time. So do we have any questions?
Yes. All right, good job, Madison. Thank you. So we have about 15 minutes left here. If anyone has any questions, we already have some starting to queue up. There is a question box on your GoToWebinar dashboard. Type your question in there, and we will get to the questions time permitting. All right, Madison, first question. How would you implement the inspection process where failures are proportional to the number of times processed? That's a mouthful.
Yeah, that's a really good question. So first we're gonna kind of stop our model. Again, you gotta stop the model to make any changes. We're gonna take our selection weights back to what was original so that we have things flowing through both areas. And then the next thing we're going to do is we're going to go into our processes and we're going to kind of change how this is done. So we're going to get rid of this decide and just have an assign. And what we want to do for that assign is we want to use an if statement. If you're familiar with programming, kind of like that. So we're going to type in math if, and that allows us to have a bunch of different conditions with different values. So we want to say if model entity times processed is greater than one or greater than 0, there's like, let's go with a 5% chance of failing. And it's important that in your mind, as you're doing this, you keep track of, okay, this is a percent of failing, because we're going to use this somewhere else. And so now let's do a model entity times processed is greater than 1. And we're going to bump it up to 10%. And then we'll do one more before we do the else value. So model entity times processed greater than 2, we're going to say that's a little bit higher of a jump this time because we're starting to get through it a few times. That's going to be a 30% chance. And then anything above that is going to be very likely that it's going to fail. So we're going to go with a 60% chance of failure. And again, now we've got something that's a little more complicated than what we were originally working with. And so this is when you want to go back and do another verification process. And this is one of the important parts of verification, is that you want to do it in little steps. Because if you just wait, it's going to be really hard to figure out what that problem is and where the problem is at, and it could take you a lot of time. So now that we've changed those values, we want to go to our selection weights and change our expression there. Remember that we set the values in our assign to be the probability of failing. So the probability of passing is that 1 minus that value. So that will be our selection weight for the passing or going to shipping. And then for our failing, we'll do model entity just quality. So that is one way to do it. There's definitely sometimes multiple ways to do something in Simio. The more you work with Simio, the more you learn, the more solution series you go to, the more you can learn about how you do things differently. Maybe you do things better so that you can figure out what's going on better. Another important thing while we're talking about selection weights, I've seen this in a few different problems I've encountered. Just because the selection weight evaluates to 0 doesn't mean an entity will not use that. And that's actually what was happening in our model, is that both pass, the selection weight was evaluating to 0. And in that scenario, an entity views zeros as, oh, this is equal probability, and it will just choose one or the other. So do keep that in mind as you're using this selection weight. A 0 doesn't mean it never ever does it. It means that it will not choose that path if there's any other path that is larger than 0. So that should answer the question of how to kind of implement that other inspection process.
All right, great, thank you. All right, we are getting a lot of questions in the queue, so I will say if we don't get to your question today, if you're on the line, if we don't get to your question before we end the session, I will bring my email address back up, so you can email me directly, and we'll make sure we get an answer to your question if we don't get an answer today. All right, next question. Madison, would you recommend splitting up a larger model into submodels and verify each one separately before combining them into a larger model?
So there's kind of multiple layers with that. Maybe instead of splitting it into submodels, you verify one of the models first and then add the second model and verify that. But also, one of the things that we definitely recommend is that you make mini models of whatever you're doing to kind of check and see what if the logic that you're trying to implement is working, and you're taking it out of your complex model. So it's definitely not a bad thing to split, but maybe you don't want to necessarily split. Maybe you want to take the concept you're trying to implement and simplify it. One thing that's really important to note when you are doing that is there may be some interactions that are occurring that you're not catching if you're splitting your model. So one of the things you might want to do is you might want to incorporate features into that kind of toy model, that split model, incorporate features that may be one of the reasons why it's not working as you expect. And there is a button feature in the animation, and a button lets you trigger some process, and so it can be an event or something. And that could be really helpful in making sure that your toy model has some of the conditions that it would expect to see if it was part of your larger model.
All right. How long does it typically take to verify a model, and what's the biggest impediment during this process?
That's a really good question. So how long it takes and the biggest impediment are kind of connected. So how long it takes depends on how much you've done it as you've been building, kind of like we talked about. And the biggest impediment is not doing it as you've been building it. Because again, and I've seen this working with a bunch of different models, when you get a lot in there and that's the first time you've ever run it, it's like, I don't know what is happening, versus other people are like, I know exactly where my problem is, I just don't know why it's happening. That's a lot easier to try to figure out than where is my problem or what is my problem. So the length definitely depends on how well you've done the verification as you've gone. And another thing that can kind of determine how long it takes is how well you know Simio and how well you understand Simio. And something that can be really useful for if you don't know Simio as well, and I'm sure some people who have been around have heard these for a long time, but sample Simbit solutions show off some of these different tasks and how they work. It's almost like a toy model with step-by-step instructions on how to use it. And then where I sit, almost like 90% of the time I am ever modeling is in this help, which pulls up the Simio reference guide. It has these great contents of how am I learning Simio? What is modeling in Simio? Like, what expressions do I need to use? This expression editor and functions has all of this really good information. And you can also use search. So like maybe I wanted to search on ranking rule, and it brings up a bunch of different options. And so if you don't know what the dynamic selection rules are and how it works, then this pulls up something that has really, really great information. So if you're new to Simio, or if you encounter something you're not sure what's going on, the Simio reference guide inside help can be really, really helpful.
All right, great. Let's try to get through one or two more questions in lieu of time here. What's the difference between the ranking rules assigned to a queue and the ranking rules assigned to a server?
So they are typically, and this may be a good one to take offline, but entry ranking rule, and this is a good thing to show, a lot of these properties have a little explanation of what it is underneath it. So you can see here the entry ranking rule is used to rank entry into this node among the competing entities. Whereas if you look at this ranking rule, this is a static ranking rule used to order seize requests waiting to be allocated to the capacity of this resource. So what kind of some of the differences is in how you use it. So if I have my ranking rule set as first in and first out, but I have my entry ranking rule set as something else, my entry ranking rule is going to determine the order that I'm picking from the queue. Whereas if I have this ranking rule for the allocated resources, that is really going to determine what I'm processing first. And there's a lot more behind the scenes about ranking rule and dynamic selection rule. It can get really complicated knowing when to use each piece. So if you want more information about those ranking rules and dynamic selection rules and even the queue ranking rules, please feel free to reach out so we can give you a really good answer about all the dynamics that go with it. But again, if you ever have a question and you're like, what's the deal with this? These little descriptions can be really helpful.
All right, perfect. All right, in the interest of time, I'm going to go ahead and steal presentation back from you, Madison. I'm going to bring up just my email address here for those that may have joined a little bit late. All right, there's my email address right there. Of course, it's going to shift over to that one. So there's my email address. If we did not get to your question today, I do apologize. We were kind of running out of time here. Feel free to email me directly, and I will get your question pushed off to someone who will get you an answer back. If you didn't ask a question and you wanted to ask a question and we ran out of time, you can also just email me directly and we'll get some answers back to you. Otherwise, I want to thank everyone for your attendance today. Real quick, just bringing up future sessions here. So about a month from now, on September 12th, From Data to Decisions, a guide to using Simio data connectors. We know data connectors are usually a pretty big topic in most of the world we deal with today, so I would expect a pretty large crowd. We're getting back from the summer break, usually in most cases due in September, so we look forward to seeing everyone in about a month. Thanks for your attendance today. Madison, great job. Thanks, everyone, and we'll see you again in a month. Goodbye.